Okay. Rectangles give you a nice picture. And you can do a lot with them and understand a lot about the use of quadratic functions, as you hopefully seen. Y'all did pretty well with this. Okay, here's another application. How do you apply quadratic functions to business? Well, one of the applications, okay? Okay, so if you sell a widget at price X, let's say the number you sell is N of X equal 10,000 minus $40X. Okay. Well, then how much money are you going to get if you sell this many widgets at this price? Now, if you sell 8,000 widgets at $60, how much money do you take in? What do you do with those two numbers? Let me pause a minute. If you want to chime in through chat, that'd be great too. So your revenue, that's the term we use. That is the money you take in is let's say R of X. Their book's going to use a little different notation, but you just get the idea here. It's R of X equals the number you sell times the price. That's a no-brainer. Everybody knows that. At least they know it until you start putting it into this context, and then so you forget what anything means. Okay, and that's natural until you work things out. Okay, so number sold times price, which is number sold times X, which is $10,000 minus 40X times X. Well, we can graph that. It's 0 when X equals 0, just like we saw for the rectangle, right? So you have a point 0, 0. And it's also 0 if this is equal to 0, right? Okay. Well, we solve this. This tells us that 40x is 10,000. You subtract 10,000, you get a negative 10,000, negative 40. Change your signs to 40, x equals 10,000. And that means x is 250. Okay. So if you sell 250 of these, I'm sorry, if you sell them for $250, nobody's going to buy one. Because the more you charge, the fewer you're going to sell. Now, if you don't charge anything, you might sell as many as you have, but you're not going to make any money, right? You're not going to bring in any money. If you charge $250, well, that's too much. Nobody's going to buy one. Now, what can you tell me about this function? It's quadratic. Your long run behavior, if x is really big, you're going to have a negative 40x squared. That's going to make x negative, right? So your long run, and we're out of time, so I'm going to do this kind of quickly, but you get the overall picture. It's quadratic. There's your long run. Here's your axis of symmetry. Where x is halfway between 0 and 250, that's at x equals 125. This is exactly what we did with that rectangle. You could even represent this by a rectangle. So we have a graph. It does this. This point is 125 what, and the what is your maximum revenue. But here's your revenue. Where's the revenue maximum? Well, duh, right here where it's highest. Okay. You're not really a duck at this point. You know, you got to sort through this. But when you think about it a little bit, it becomes obvious. Well, yeah, that's going to give you a maximum revenue. Okay. And it's a maximum because you have that negative 40x squared there, which makes the thing open downward. Well, that's kind of interesting. Now, one other thing. That's not your profit. For your profit, you've also got to subtract how much it costs to produce these things. Okay? And that'll be a multiple of x. So then you're going to have an x in here, and that's going to shift your graph this way or this way. But we'll worry about that later.